As our last second semester exam review portion, we learned how to graph trig functions. We learned how to graph sine and cosine together, and we learned how to graph tangent and secant and cosecant very quickly. In terms of graphing sine and cosine functions, remember that I would probably also put something on the non-multiple choice section, like a word problem. We'll talk about that very soon. All right, how do we graph one or two periods of y equals negative 6 sine 2 times x minus 5 plus 4? We can tell that the amplitude is 6. We can tell that the vertical shift is 4. I can tell that the period is 2 pi divided by 2, so pi. And I can tell that the phase shift is to the right 5. So as I've shown you in the past, if you do things in a certain order, it tends to go well. Since the vertical shift is 4, pencil in y equals 4 as the midline. Since the amplitude is 6, then the highs are going to be at 10 and the lows are going to be at negative 2. All right, next, the phase shift is to the right 5. So that means if we go out to the tick mark 5, oh boy, that's going to be awful. Let's make this a pi over 5. So let's make the first tick mark pi over 5. Okay, so now if we take the period divided by 4, we get pi over 4. So we want to label 4 more tick marks, and we do that by adding pi over 4 to the previous tick mark. So pi over 5 plus pi over 4 is 9 pi over 20 is the second tick mark. And then if I add pi over 4 to that, that's adding 5 pi over 20. Then that would be 14 pi over 20 for the third tick mark, or 7 pi over 10. And then if I add 14 pi over 20 plus another 5 pi over 20, we get 19 pi over 20. And then if I add pi over 4 one more time, I get 24 pi over 20, or 12 pi over 10, or 6 pi over 5 for the final tick mark. Okay? Now we draw a negative sine function by going middle, low, middle, high, middle. And so we have our sine wave. Sorry about that mistake on making the phase shift to the right 5. We're going to make that pi over 5. Okay, let's try this one. The vertical shift is negative 8. The amplitude is 4. The period is 2 pi divided by pi over 5. That would be 10. This time it's okay to say that the phase shift is to the left 1. So let's see, we draw our y-axis, draw our x-axis, and then we draw y equals negative 8 as our midline. Amplitude of 4 takes us up to negative 4 for the highs and negative 12 for the lows. Okay, now the phase shift is to the left 1, so I'm going to label a tick mark negative 1. And then 10 divided by 4 is 2.5, so I add 2.5 to get the next tick marks. Negative 1 plus 2.5 is 1.5. That plus 2.5 is 4. Plus 2.5 is 6.5. And plus 2.5 is 9. Okay, so those are our next tick marks. The cosine wave would be, not there, sorry. High, middle, low, middle, and back to high. So we would have our cosine wave fluctuating around down there. Okay. Cosecant and secant functions. Cosecant is the reciprocal of sine. So what we do to graph a cosecant function is we graph the sine function, and then we draw the little parabolas and asymptotes where they belong. The amplitude is 4, the vertical shift is 1, The period is 8, 2 pi divided by pi over 4, and the phase shift is left 2. Okay. So this time we need a tick mark at -2. And then if you take the period divided by 4, you get 2. So the second tick mark is at 0, then 2, then 4, then 6. The vertical shift is y equals 1. And then plus 4 is 5, and minus 4 is -3. So let's draw a sine wave. Middle, high, middle, low, middle. Now, we draw that dashed because we're not drawing our sine function. We're drawing our cosecant function. So you pencil in an asymptote wherever the sine wave crosses the midline. That's where the cosecant function would be undefined. Then you just draw a little parabola looking thingy that touches each high point and each low point. And so the black graph is your cosecant function. Y equals 3 secant 6x. Secant is the reciprocal of cosine, so if we graph the cosine function, then we can draw the secant function. So let's see, the vertical shift is -5, the amplitude is 3, the period is 2 pi divided by b, so that would be pi over 3, and there is no phase shift. All right, so let's see, we draw our y-axis, we draw our x-axis, and the vertical shift is at -5. The amplitude is 3, so that means go up to -2 and down to -8. Okay, the period is pi over 3, but since there's no phase shift, that means the first tick mark is at 0, and the fifth tick mark is pi over 3. And then if we divide pi over 3 by 4, we get pi over 12 as our scale. So 1 pi over 12, 2 pi over 12, 3 pi over 12. Those are our other labels. Okay, now draw a cosine wave. So we would go high, middle, low, middle, high. So let's dash in the cosine wave, and then let's draw asymptotes where the cosine wave crosses the midline. And then let's draw our little parabola thingies touching those high points and low points. And there you go, you have your secant wave drawn. Okay, last example, how to graph a tangent function. Okay, remember we take a slightly different approach. We call it not an amplitude of 3, but we'll understand what to do with that, a vertical shift of 2. So what that means is that you pencil in, just like with the sine and cosine functions, y equals 2 as the vertical shift. Now, add 3 to that and you get 5, and subtract 3 from that and you get -1. That's where two major points are going to occur. Okay, now remember this. To find the asymptotes, you set the b times x minus c equal to pi over 2, and you also set it equal to 3 pi over 2. Why? Because that's where the parent's asymptotes are. Okay, so let's see here. If I divide both sides by pi over 7, I get x minus 1 equals 7 halves. And then think of that as 3.5. This one would give me x equals 4.5. If I divide both sides of this next one by pi over 7, it looks like I get x minus 1 equals 21 over 2. And that's 10.5. So then won't this give me x equals 11.5 as where the other asymptote is? So now, if I label a tick mark 4.5 and another tick mark 11.5, then pencil in your asymptotes there. And then just put 3 equally spaced tick marks between the 2 asymptotes. And at this low -1, put a point at the first tick mark. Put at the second tick mark a midline, and put at the third tick mark a point corresponding to 5, and draw your little squiggly tangent function trapped between those 2 asymptotes. All right, so this is the last review video that goes through the review problems. Hopefully this will help you keep working on your review sheets.